Hello everyone, welcome back to the channel. Now in this video we are going to learn something about bit manipulation. So what is bit manipulation? It's manipulation of bits. I know that's I know that's quite straightforward, but that's how it is. In in last video we understood something about mathematics, right? Maths operations. We perform addition, subtraction, divide, multiplication and mod. Those operations are not directly performed in the processor, okay? Because our computer understand only single thing, okay, which is a binary language, that is either 0 or 1. So your computer does not understand anything beside these two things, which is 0 or 1. Now when you perform those mathematical operations, right, your computer has to convert it to something that it can understand, which is again binary. But then you have this bitwise operators. So if you make use of these bitwise operators instead of using those mathematical operators, right, your operation will be much faster. Okay, so that's what we are going to learn about in this video, which is bitwise operators. So as the name says, bitwise operators, okay, now these operators are actually performed within 2 bits. Now what is a bit, you might ask? A bit is the smallest unit of calculation for the processor in the computer. Now I told you computer understands only 0 or 1, right? Now that is 1 bit. 0 is 1 bit, 1 is 1 bit. Okay. So the operations performed between these two bits is called bitwise operations. Okay. Now as I have told you, it's fast in processor. If I have to give you an example, let me give an example. Let me share an analogy of you talking to your friend. Now you have something to share with your friend, okay? You can call your friend, share that information right away in a way that you and your friend understands. Now let's say you called your friend but he or she is not picking your call. You called some other friend, right? Now that friend called his parents or her parents, then her parents pass this information to someone else, and that someone else passed the information to your friend. Even let's say in a hypothetical scenario, your information is intact, there was no manipulation in the information that you shared, but the time that it took from you sharing that information to someone till the time that information reaches to your friend, that's a lot of time wastage. In case of bit, we save that time. Bits talk directly to processor, you talk directly to your friend. You understood the analogy there? Now let's get into the actual bit operations. So first one is bitwise AND. What it does, it converts the operands which you are using before and after the AND into a binary number, and then performs the bitwise AND operation, and then converts that result to a decimal representation, and then returns you the answer, right? Now what do you mean by bitwise AND? Bitwise AND means basically when it converts to binary, right, you will have those 32 bits of number. Now why 32 bit? Because in Java integer takes 4 byte. Now in 1 byte there are 8 bits. Okay, if you multiply 8 into 4, right, you will get 32 bits. So that's why I'm telling 32 bits of first number, 32 bits of second number. Now AND operation means wherever you have 1 at the same places, and that is where you will have 1 in the result as well. When that operation performs, you get your answer, and then that answer is converted to a decimal representation. Now something similar happens with bitwise OR as well. It also converts to binary. Thus the bitwise OR operation, that means either in the first number you should have 1 or in the second number you should have 1. Either of them has 1, right? The answer you will get 1 only. It will perform that operation, it will convert the result into a decimal representation, and it will return the answer. Now XOR means those bits should be different. If you have 1 in the above, you're supposed to have 0 in the down. If you have 1 in the down, that means the second number, you're supposed to have 0 in the first number. So if the bits are different, right, then only you will get 1 in the result. That's what XOR means. Okay, otherwise you will be getting 0 only. So whatever the result you get after this XOR operation, it will convert it to again your decimal and return the output. Now the XOR, it is also known as bitwise complement. So let's say you have a number, right? Let's say you have 3, 4, 2, whatever number you have, you converted it to a binary. Then the bits that you have for that number, right? It will just reverse it. If you have 0 in the number, in the reverse it will become 1. If you have 1 in the number, it will become 0. Now that reversal, right? We call it complement. Okay, that reversal will happen you when you use this bitwise not operator, right? Converts to binary, inverts every bit. And then you have a left shift operator. What left shift operator what left shift op, what left shift operator does, it converts it to a binary, okay, shifts the bits to the left, okay. And how much you're supposed to shift these bits, that you mention like this. Let's say you want to shift x 1 times to the left, or you want to shift x 2 times to the left, you mention it like this. That's what I have mentioned here as well. Shift x bits time to the left, shift x bits 2 times to the left, and here is your expression. Same thing we are doing in right shift as well, right? Converts to the binary and shift the bits to the right like this. Now there is unsigned right shift as well. Now when you're doing this right shift, right, it considers the scenario when you are passing negative numbers as well, okay, signed bits. But if you are using unsigned right shift, right, now there are the differences. Here you have one more of this arrow, right? Now this is our unsigned right shift and this is the right shift. So in this one, what happens, you perform the same operation, but it replaces the 0 even if it's a negative number. That means 0 means basically the first bit that you have, right? That is actually a signed bit. I know it could be a bit tricky to understand, but when you have those two numbers in your pen and paper somewhere, right, you have those binary numbers, you have written the first number, the second number, then you're trying to do the calculation, right? You will understand these operations very well. Now that's what I'm talking about in this place. Even if you're passing a negative number, right, it will ignore the signed bit. That's why it is called as unsigned right shift operator. Same thing, we just, we have taken some variable and we have applied these operators on some operands. We have taken some variable. If I run this, you will get the answers according to the operators that we used here, okay. Now how we are getting this, in the same way that I have explained you here. If I go ahead and start explaining each one of these, it will take so much time, and it's not like I'm going to ignore this or not going to explain this, but we are going to explore more on this when we do the problems on bitwise operations, okay. There I can actually show you how much different does it make, right? As for the concept wise, to understand bitwise operators exist and they could be useful and why they are useful, that's why all this is your bitwise and this is your bitwise or, bitwise XOR, bitwise not, bitwise left shift, bitwise right shift, and bitwise unsigned right shift operation. As part of this video, consider it just like an introductory or conceptual video for the bit manipulation, okay. And we are going to learn about more concept, and when we do the problems, we are going to explore these concepts in depth as well. So that's all I wanted to explain as part of this video. See you in the next one.